Hi everyone, so we're going to have a look at hypothesis testing, and this example is going to be what's called a one-tail test, and you should have had a look in last week's lesson at a PowerPoint that explains some of this notation. But let's have a look at this together. So 4 students are playing a game of chance. Now because it's a game of chance, what that means is that it's just a random game, so the probability of winning this game for each person is 1 out of 4 because there's 4 people playing and one of them got to win each time. So they're playing a game of chance, so they've all got a 1 in 4 chance of winning. In a random sample of 10 games, so they play this game 10 times, Connor wins 5 times. And when this happens, Linus accuses him of cheating. Okay. And what we're asked to do is to test at the 5% level of significance whether there's any evidence to support Linus's claim that Connor was cheating, and so that his probability of winning in some way is increased from a quarter and is higher than a quarter. Okay, so let's have a think about setting this up. So x, our random variable, is going to be the number of games that Connor wins. Okay, and it should be, if he's not cheating, so we go for the default value of it just being a game of chance, that nothing's changed from the probability, it should be a binomial distribution. N is 10 because we play 10 times, and the probability of winning, if nothing's changed, if he hasn't cheated, is a quarter. So this is going into our null hypothesis. So our null hypothesis, we always write these down, H0, so null hypothesis, so nothing's changed, this is sort of our default value. Our null hypothesis is that the probability of success is definitely a quarter. Okay, now our alternative hypothesis, the hypothesis that Linus wants testing, is that something has changed here and that the probability of winning has increased because it's saying he's more likely to be winning. So Linus thinks that he's done something, mark the cards or whatever, to say that his probability of winning is now greater than a quarter. And in one of these questions in the exam, just writing this bit down here, these 3 things down, generally is worth 1 or 2 marks every single time. Even if you don't know what you're doing for the rest of it, this is always going to be worth 1 or 2 marks, so make sure you get that written down. Okay. So what we're doing, we assume that H0 is true, so we assume that it's binomially distributed, probability is a quarter, and we have a look at what would the probability have been of Connor winning 5 or more, so at least 5 times, so not just 5, we want to do greater than or equal to 5. So what's the probability actually, just by chance, of Connor winning 5 or more times anyway? So that's what we're going to do. So the probability that x is greater than 5. We're going to use the binomial CD on our calculators, but don't forget our calculators can only do a less than or equal to probability. So if we think about this number line, what we want the probability of winning greater than or equal to 5. So this is the bit that I want. So that's going to be 1 minus everything less than or equal to 4. Okay, let's get our calculators on the go. So we'll get into statistics mode. I want the binomial CD because it's a less than or equal to. I want my variable because I know my value of x. X is 4. My number of trials is 10. And my probability of success, if nothing's changed, is a quarter. So that's 1 minus 0.92187. So let's just get the exact value of that. So 1 minus that answer is 0.0781, etc. Now what does this mean? So that means that basically there's around about a 7.8 chance of this happening anyway, just by chance, just if nothing happened in this game, if Connor didn't cheat, there is almost an 8% chance of this happening. And actually, statistically, that's reasonably large, and it's definitely bigger than this 5% cut-off point that they've told us in the question. So test at the 5% level whether there's evidence to support Linus' claim. So at the 5% level, there definitely isn't, because this is greater than 5%. So we say, actually, there's a reasonable chance of that happening. There's about an 8% chance of Conor winning 5 times anyway. So he might not have cheated. There's no evidence to say that he's cheated. Okay, doesn't mean he hasn't cheated. It means statistically there's no evidence to show that. So if he did, he's got away with it. Okay, and what we should do at the end of this is write some sort of sentence here. So here we would say, therefore, at the 5% level of significance, there is not sufficient evidence to reject H0. So in this case, there's not sufficient evidence to support Linus's claim of cheating. Okay, so that's our first example. What I'm going to do is stop the video now, and then I'm going to record another way of doing this question, which is to look at critical values, which basically means how many games would Conor have had to have won for Linus to have some evidence of some cheating going on. Okay, so have another little go through that, maybe play this video again, and I'll upload the next video in a second.